Good morning to all of you, people who are joining from different time zones. So here also, my name is Amit, and I'll be your instructor for today. To have a discussion on the data engineering, right? So I come with more than 10 years of experience of working into data science. I work into, the data engineering, use the tools like Tableau, Power BI, SQL, NoSQL, MongoDB, right, Scala. So the kind of tools that we use extensively into the field of data engineering, data science, and a lot more, right? So definitely we are going to talk about a lot today in this session about data today. So to start off with, right? So when we use this word data engineering, all right. So there are a lot of buzzwords today that you all would have heard, right? So there is something like data science, data engineering, right? We about business data, data power, right? Data lakes, Azure. So there are lots and lots of terminologies that have come today across, when it comes to data today. But the point that should strike to us is, why are we talking about data so much today, right? Why are we talking about data? What has happened is, in the last couple of years, what has happened is the data generation has increased, right? The data generation is something, which has increased exponentially, right? If I just go by certain numbers, right? So if you just Google it out, you read about it. So there's almost like 2 trillion, right? GBs of data is what we all are creating on a daily basis, right? Each day, all the organizations, companies around the world, this is the amount of data, that they are generating across the globe on a daily basis, right? And this data is regarding, the users, markets, products, transactions, right? Web data, etc., etc. There are a number of sources through which this data is getting generated, right? What's the reason behind this? Why are we generating the data so much today? Right? In fact, there was a statement from one of the top Microsoft executive, the amount of data that we have generated from dawn till 2013, right? Dawn as in from the time we understand that the data generation had started, and the data generation was picking up, right? So from there, what has happened is the amount of data that we generated till 2013, same amount of data, right? Same amount of data we have generated in the last 8 years. So this is the same amount of data that we have generated in the last 8 years now. So again, the question comes, why, right? What has changed in this couple of years that we have started generating a lot more data, right? The answer for that is digitization, right? So what has happened is, with this digitization, the amount of data that we have been generating has increased exponentially, right? So when we talk of digitization, what exactly it is, right? That's basically internet. So today, if you all see, right, I mean, none of us can actually expect a life without internet today, right? You have to book a cab, you have to book a vacation, you have to do a banking transaction, you have to buy the groceries, you have to order the medicine, you have to order the food. I mean, you name the thing. I mean, I'm sure, right, today we don't think of going to a supermart. We don't think of stepping out for buying our day-to-day tasks itself, right? If you have to go for entertainment, right, you can watch the movies on the go. Gone are the days, when we used to download the movies. Gone are the days, when we used to take the movies from our friends in the pen drives and all those things, right? All those things are today available on the internet. And in fact, these are the services that I have talked about, right? This is about the services that I have talked about. But now, even our gadgets, right? Gadgets are connected to the internet, right? So like when we talk of gadgets, right, like you all would be using, smartphones, right? Watches, Alexa speakers that we have, air conditioners today are connected to the internet, our lights, right? These days, all the lights that we get, everything is connected to the internet, right? So technically, if you see right now, all these things that I've mentioned over here, they are responsible for the generation of the data, right? So in our instruments itself, right, our instruments, our gadgets, they are also, are something which are generating the data today, which is something, is something tremendous, right? Which has actually led to this complete bubble burst of this data today, right? So if I just give you some small examples, right? If like, and these are some applications that we all do, right? There are almost like 25 million text messages, right? 25 million text messages that are sent every day, right? There is almost like 7 lakh hours, right? 7 lakh hours of Netflix watched 60 seconds, right? In 60 seconds around the globe, 7 lakh hours of Netflix is watched. Within 60 seconds, there are almost like 11 new Spotify songs that are uploaded, right? And in fact, you all would be aware, right? Like this, when we talk about all these firms, right, which is called as MAG, right? When you hear of this Meta, Amazon, Apple, right, Netflix, Google. Now, these are some of the organizations which are actually responsible for the highest generation of the data. In fact, Spotify is also something which is now, basically generating huge amount of data, and they are using the data in different number of possible ways so that they can, give their listeners the best choice of the music, right? Similarly, Netflix uses the data to understand what kind of movies the people are enjoying across the globe, so that they can show the right kind of titles to its the viewers over here. So this is where what has happened is this amount of data that we are generating has led to the bubble burst of this data field today. And in fact, as per the latest predictions, right? In fact, this data is going to grow up more exponentially in the upcoming years now, right? Because as you know, with this pandemic, right? In fact, the pandemic, what had happened was the things were actually driven by internet and digitalizations more aggressively as it was happening before pandemic, right? There has been a change in how the people, their choices have changed, their way of operation, their way of working, and their way of living has changed over the years, due to which this data, the field is something which is now catching it even faster, because organizations today, they want to stay to the top to understand what is in the demand. Okay. So in fact, there are revolutions that have happened, right? There are revolutions that have happened, right? Revolutions now, I am sure you all would have heard this term in your school, but this is something which actually works, and we are into the fourth revolution today, right? In the first revolution, what used to happen was we used to have man-made objects or services. We had man-made services, right, or products, right? What do I mean by that is that in the first revolution, human beings, they used to create some products or they used to offer services. In the second generation, what had happened was we got machines, right? We got machines. That machines took up the work of men, and machines were used for doing our tasks. In the third revolution, what had happened was we got computers, right? In the third revolution, we got computers. The things went to the computers. Now there were softwares, right? Software development, right? Because and there was a big bubble that had bursted into the computers at that point in time, right? If you all recall, right after 2000, right, Y2K, which we had after that, there was a bubble that had happened into the software development. C, Java, all these languages were like on their boom, and all the people were actually learning those coding languages and everything for their career, right? Engineering took a boom at that point in time, and the people, they were aggressively hirings that were happening, and new softwares products that were getting created during that particular time. Now in the fourth revolution, we have entered into the era of internet. Right now, this revolution is the revolution of internet, in which now everything is happening over the internet, and which is actually where the data scientists and data engineers have now come up into the full. So now when we talk about data science, right? Data engineering. So you all would have heard that there are lots and lots of different type of, the profiles that are there in the market, right? So we have data scientists, we have data engineers, right? We have data analysts. So now, how are all these things connected, or how are these things different from each other? That is exactly, what we are actually going to talk today about. See, what happens is, like in every organization, huge amount of data that is generated, right? So in every organization, there are different teams, right? Every team will be generating its data, right? Then every team might be using a different software. Some might be using some Excel, some might be using some database, right? Some might be using, some PDFs, notepads, or any other source of file, right? There will be different teams and different type of data that these organizations would be generating. Now, and the data is not just limited within the organization. No, data is something which comes from outside the organization as well, right? Some examples, if I talk about, website data, right? web data, right? Like how the people are accessing your websites and how many people are coming to your websites and all, how many Google searches are happening for your organization, for your products, for your services. That is the web data, right? Then what we do is we generate something like market research data, right? Market research data is like the data about the competitors, right? The data where we want to understand what competitors are selling, what price competitors are selling at. So that's a market research data, right? There will be a data which will be more like surveys data, right? Organizations, they organize surveys. So there will be a survey data that will be generated. So if you see right now, this data that we are talking about is something which is being generated by the different file format, the different sources, and data could be structured, unstructured. There are multiple things that are happening over here right now. And in fact, when you talk about the product companies, right, like I was talking about the Alexa and all, in those cases, the data is being generated by the instruments also, right? Instruments are actually generating some data for you, like what kind of things people are looking out for. So those instruments are also giving you some data over here now, right? So now, as a data engineer, right? So what happen is you have to, first of all, create a infrastructure which can actually help you extract the data from these different data sources, right? You have to extract the data from these different data sources. So you need an infrastructure for that. Okay. Now, when you will extract this data, right? For this, we use this term, which is E, right? Which is E. E stands for extraction. Once you have extracted the data from these different teams, different sources, then what will happen is you will need some transformations, right? All this data that we will need to have some transformations on it, right? Transformations in the form of that this data might not be cleaned, right? This data might have duplicate information. This data might have some missing information. This data might have, some bad data, right? So all that things have to be transformed. Those things have to be transformed. So this is basically, we are talking about right now hierarchy, how that hierarchy works. So you are collecting the data at the first step and you are transforming that data and cleaning that data. And then finally, what you do is you load that data into one single place. You bring all the data into one single place now. That is how that entire process goes in. Okay. So this layer, that I've talked about over here, this layer that I'm talking about over here right now, this layer is basically called as, the data infrastructure. And for this part, what we have is we have the data infrastructure engineers, right? These are the people who will be, maintaining and collecting all that data now. After that, that data that is collected, right? After this data that is collected, which is extracted. So majorly then what will happen is the next part will start where what will now happen is comes the section of data engineers. Now, data engineers are the people, who will be now creating a reliable data flow, right? Like all these data sources that we had. So the data that you are extracted. So now these data engineers will be the people who will be creating a complete data flow, setting up the infrastructure, defining the pipelines, right? Creating the pipelines and organizing the structured and unstructured data storage, right? From wherever the data is structured, that store it that in a proper way. If the data is unstructured, save that in a proper way. So those engineers, data engineers would be the people who should be good with the data modeling, right? They should be good with SQL, NoSQL, Scala, certain programming languages, right? Like Python and all, right? Python is actually used a lot for, setting up the ETL pipelines. Okay. Now this is exactly what a data engineer would be doing now, right? So if I just quickly mention it out, right? As a data engineer, the guy, what he would be doing over here is he will be creating a reliable, right, data flow. Is something who is going to set up the complete infrastructure, creating the pipelines of the data, right? And doing ETL tasks, right? The person will be responsible for, structured and unstructured data storages, right? These are the kind of things that a data engineer is going to do. Now, once your data pipelines, data flows and everything is created, now that is when what happen is that data can now be used for the purpose of analytics, right? It can be used for the purpose of, you know, creating, machine learning models and everything, right? You start with the reporting, You use the tools like Tableau, Power BI, the reports and all those things are created. And in that, you also do certain things, right? Like setting up machine learning algorithms so that you can do the predictions, classification of the data, you do the A/B testing, right? Now, these are the kind of tasks which will be taken care of by these tasks are something which will be taken care of the data scientists or the data analyst. So there are two kind of people, data analysts. Data analysts are the kind of people who are majorly responsible for, right? They are the people who are responsible for creating the reports, and data scientists are more people who are responsible for creating the machine learning models and everything. Now, after that, right, what happen is once these machine learning algorithms and models are also done, then comes the next layer where what happen is we start doing some AI or we start doing some deep learning things. Right now, this is the layer where what happens now is you need the machine learning engineers. Here you have the data scientist, here you have the machine learning engineers. So if you technically see, data engineers are the people who are the foundation of any organization for setting up how that data will come, right? Because if that source of data would be not correct, so what will happen in that case is all the other things, right? Machine learning, reporting, all the things will not make any sense, right? So what happen is, like for example, if you want to understand this with a small example, right? When a company makes any product or service, right? Or they are into service offering certain things, they need valuable information to understand their market, right? Every organization, whenever they start their business and all, so what will happen is they will need the complete information regarding their products and services. Now, that information is something which will help them to create new products, understand their customers, and it will help them to also get the information regarding their competitors, right? So before the world starts to collect data to feed what we call big data, businesses have no choice to do their own analysis, right? They have to use their, because till that time, what used to happen was when the data, big data, and all these things were not there, companies and organizations, they used to take their decisions based on their intuitions, right? They used to do their own analysis. I know that was a technique that we used to call it as hippo algorithm. Anyone has heard about hippo algorithm? See, hippo algorithm is highest paid person's opinion. Right. Now, the highest paid person in any organization is the CEO. So earlier, what used to happen was whatever decision CEO used to take, that used to be floated across the companies and the companies used to abide by that. But now what happened is the decisions are not taken just by the CEOs. There is a data that sits behind. Based on that data, what happened is the decision is taken up, right? So now, like as I was telling, the modern technologies of big data, right? They are the fourth revolution that we all are into right now. And all this big data that we have today, right, is something which offers the tremendous amount of opportunities, right, to create better business, organizations, charities, and much more, right? So that is where if I come back over here, right? If you all understand this now over here. So as a data scientist, a person is responsible for mathematics. He should have the skills of mathematics, programming, and communication, right? When it comes to data engineers, these are the people who should be good with programming languages, mathematics, and big data, right? Understanding of big data is something which is very, very, very important, right? When it comes to using the skills, right? The kind of skills a data scientist would be using, he would be using like SQL, Python, R, right? And when it comes to data engineer, he would be using the skills like Hadoop, NoSQL, Python, right? Now the use of Python will be different because Python is a very versatile language. It can be used for web development, application development, data science, data engineering, graphical user interface creation. So that way over here, Python, the use of that Python will be a little different, and the person will be majorly working onto the concept of OOP side, right? Object oriented programming. And when we talk about data analyst, right? So data analyst is more of a guy who is more responsible for creating the reports only, right? So now over here, they must be the people who should be good with Excel, Tableau, and SQL. Okay. So data analysts, they are also called as business analyst, and data engineers, they are the people who are also called as database administrators or data architects, right? Because these are the people who are designing how that data has to be managed and it has to be stored. So now you know how the things have changed, right? In the field of data science, right? So that's what we will talk about. So now, you know, over the period of things, what has happened is now, you know, we have more data. And because of that, we are able to generate more insights and we are able to have more performance driven results based on that, right? Because of this data, now there are organizations and cultures that have been set it up. So as the decision making that happens is something which should be happen on the basis of, you know, the proper data analysis and the data in the backend. Then data engineering, which plays an important role, right? So with the data engineering, now what has happened is that proper implementation and pipelines have to be created, which are then used for the proper data, you know, analysis. We have more productivity tools. And the biggest change that is happening is the things are getting cloud enabled. Right now, all the things that you will see, right? So all that data storage, data, you know, pipeline creation and everything that we are talking today has moved to the cloud, right? When we talk about cloud like Google, this the Azure, right? Microsoft Azure that we have, AWS. So the things are moving on to the cloud platform today. So in fact, you know, organizations, right? So I've worked on multiple projects where, you know, the organizations previously used to have all their data on their on premises, right? On premises means data used to sit in their own servers. Okay, they have their own servers where data used to sit, data modeling was done, and you know that, you know, over there the things were always on their own system in their own firewalls. So what are the limitations, right? Can you think of any limitation of having the premises or data sitting in your premises only? See, what happen is if we are using on-premises servers, see what happens is if your data requirement increases, so you will have to upgrade your servers, which can take time and effort. But when we are on the cloud, so what happens in that case is the things can be upgraded on the go. You just have to, you know, upgrade your services and within couple of minutes, all your hardware and your performances, everything will be upgraded. And likewise, if you want to downgrade it, right? Tomorrow, if you feel your data has reduced down and you don't unnecessarily want to pay for the high storage or high performance, you can trim it down as well, right? But in the on-premises servers, you can't do that. You know, once you have established all your infrastructure, so making modifications to that, you know, always becomes very, very expensive, right? So what is happening over here right now is over this period of time, so data is something which has increased abundantly. And that is where again the data engineers are something which come into the play now. Now, data engineers, what they do is they will collect relevant data, right? They move and transform data into pipelines, right? They move the data into pipelines. And these are the people who must or they should be good with the codings such as, you know, the Python, right? They must be good with the codings like C++, Java, and Scala, right? These are the languages that a person should be good with in order to work with this. So technically, you know, if I define what exactly and how exactly data engineer is going to work, the technical part is he has to design, right? This person has to build, right? This person has to basically arrange. These are the three things that this person is going to be responsible for all his works related to the data, right? So they are basically the data architects, right? So these are the people who are mostly, you know, from computer engineering background, data science background, you know, or system creation skills. This will be the background of these people, right? So what exactly is a data pipeline now? So the question that might would be, striving in your mind would be pipelines. So what exactly are pipelines? See, data pipelines are sequence of processing, right? It's the sequence of processing, right? And analyzing and analysis steps applied in the data for a specific purpose, right? Basically, for these people, right, for the data engineers, there is a motive, there is an objective that has to be defined, that what exactly the purpose of all that setting up of the pipelines is, because that data that would be flowing from there is something which will be something which is going to be used by the different teams. So that is where that pipeline creation has to have an objective. What should be the end result of that data that is going to get flown out of it? So now as so like for example, let's try to understand this thing with a small example right now. So what will happen now is, say suppose we are talking about a small like for example, let's talk about an e-commerce firm right now. So what will happen right now is, if you order something on an e-commerce, right? So there is an order ID that is generated, right? There is a date, on what date that order was, kind of purchased. There is the information regarding the customer ID, customer name, address of the customer, right? There will be the information regarding the product ID, product name, right? The price of the product. There will be something related to the sales of the product, right? There will be information regarding the supplier who is going to deliver that product. There will be supplier name, right, who is going to deliver that product. So now this is a very small example that I'm telling you to understand what exactly and how that the pipelines and everything is now created as well. So now what happened is, like, this is the in-house data that would be getting generated within the organization now. Okay, so if I say there was an order that was sold and the order date was this and the customer ID was C1, it was purchased by Sam and his address is lane 1. He lives on lane 1. He ordered something like, an iPhone. The price was, say, suppose 50K, and the sales value, he purchased 1 unit, so that becomes 50,000. And supplier ID is S1 and supplier name is, say, suppose ABC Mobiles. Right? This is the information that is generated for that first order that was sold. The second order that was sold in that same date, another customer came in. His name was Jack and he lives on lane 2 and he purchased the product P. He also purchased an iPhone only, same price and everything. Same thing. Then third order was sold, on the same date. Third customer came in, C3, and his name was, say, suppose Dave. He lives on lane 4, lane 3, and he also purchased an iPhone. So now what happens over here is these are the different products that have been purchased. Now, then what happens now is there was a next order that was sold. So now I was trying to talk about this small example over here, right? Okay. So now this is the data that I have, right? In this, what I'm doing right now is, so now on the same date, what happens now is the customer whose ID is C1, he comes back, right? So his address remains the same. Just that this time what he has done now is he's going to purchase a different product, right? He purchased, say, suppose a charger worth rupees 2000, right? And the sales value was same 2000. And S1 ABC Mobiles is the same supplier who's going to deliver that product as well. So now, if this is the data, right? So this way, if I store this data is something, which is going to create a lot of troubles for me, right? Because what is happening in this data is that, there is a lot of duplicate data that I have stored over here in this system right now, right? So I'm saving, iPhone again and again, the ABC mobiles again and again. So with this, what will happen is if I'm unnecessarily saving the same data multiple times, so what happens over there is, right? So in that case, what will happen is I would unnecessarily be wasting my, memory and the performance of my systems and everything is going to go down, right? Because if I'm talking about some big organizations, right, like the organizations like Amazon, Google, right, they are something which are generating huge amounts of data. So for example, the Amazon, right, it would be selling millions of iPhones on a daily basis itself, right? So I can't keep writing that thing again and again. So what a data engineer would be doing is he would be responsible for doing some proper data modeling, right? Probably he will do what he will create a sort of a data model. So like I create a customer table, right? Customer table, what I do over here is I'm going to keep all the customer ID, name and address, right? Okay. Now in this, I will keep this. Similarly, if I'll, come over here. So now in this table, I don't need to maintain customer name and address multiple times. If you see, C1 customer came to my store to purchase something. So his name is already logged into my account that he is Sam and his address is Lane 1. Similarly, if I talk about, something like, you know, we can make a product table. In the product table, what we will do over here is we will keep all the product information, right? Product data, product name, and the product price. Now again over here, I really don't need to keep the duplicate information. So if you see now, I will see that I am selling P1 is iPhone, price is 50,000. So now what happens over here is I'm going to remove these columns from here. And similarly, when it comes to supplier data, right? So we will have a supply table. And in the supply table, what we will do is we will keep the supplier ID and the supplier names, right? So now with this, now what happens over here is I am having, the supplier ID and supplier name saved in this. So with this, now what's going to happen is I have reduced down the duplicacy of the data, right? The duplicacy of the data is something which has been reduced down. So here what we need to do is we need to create, the data model. So, we will be making a model over here. So now in that modeling, so what I do is probably, I can, if I see this was the main table, which I'm going to call it as fact table right now. So I have all these IDs over here with me. Okay. In the supplier table, I'm going to have supplier ID and supplier name in this. Right from the customer table, I have all this customer information with me. Right. And we have the product table where we have all this information with us. Right. So now what we do over here is we actually set up the relationships and define a complete model over here right now. So like, for example, I come over here and I'm going to say that supplier ID to supplier ID, right? We will have something like product ID to product ID, right? We will have customer ID to customer ID, right? So if you see over here, this is a relationship that we have created, and this is how a data would be maintained. Right now, this is more about, right? This data that I've shown you over here is something which is more about in which, we have, you know, a relatable data, right? But in real time scenarios, what happen is the data can be, I will say very scattered, and you might have a non-relational data as well, right? So that is where, what happen is the data, the engineers are the people who are, they are also expected that they should have the good understanding on NoSQL, right? So when we talk about NoSQL over here, right? So see, SQL will always play a very important role over here. Now, NoSQL is something, which is something which originally refers to non-SQL, right? Or non-relational, you know, databases, right? So now they provide this mechanism for storage of and retrieval of data from the from the non-relational data set, right? So this data is modeled, in a means other than the tabular formats, which are actually used in relational databases, something that I was showing you over here. Now what happened is these kind of databases, right? The non-relational databases, they came very early into the existence around 1960s only. But recently, this has become a rage in the industries, right? Now, the example of a NoSQL database is your MongoDB. So a non-SQL database is something which includes simplicity of design, and it has simple horizontal, scaling the data in the form of clusters and have final control over the availability of the data as well. Now the data structures, that are used in NoSQL databases are different, which are used in the, I will say relational databases, right? And also they make the operations faster in NoSQL. So the different data structure models that we use over here, they are faster as well, right? And the suitability of a given NoSQL database depends upon the problem that you are trying to resolve. And data structures used by NoSQL databases are also are viewed as more flexible as compared to what data structures that you have in the a relational database now, right? So what happened is like in the relational databases, over there we follow the concept of ACID, right? ACID, which stands for atomicity, consistency, isolation, and durability. But over here, the most of the the NoSQL databases, they lack ACID, right? I mean, they do not follow the same properties, right? So most NoSQL databases offer the concept of eventual consistency, in which the database changes are propagated on the nodes, so that query for data might that can return most updated data immediately, right? Because right now things, what are now happening is that the companies now want data analysis and data computation right at the generation of the data itself, right at that same time when it is generated, right? So like, for example, when we talk about smartwatches, now in the smartwatches, what happens is as you are walking, your steps are being counted and some calculation is also happening, that how many steps you have walked, what are the average steps that you have walked, at what time you walk more. So those analysis are something that you get right away, right? That is called as computational, the data analysis, where data generation and analysis is happening right away. So that is where these NoSQL databases also help us in creating that up. Now what happens is these NoSQL databases that we have, they have high scalability, right? These are something which have high availability. These are the reasons they are becoming so popular today, right? And the disadvantage of the NoSQL is that they are mostly, first of all, they are more open source, right? Because since they are open source, so the reliability is less, right? Plus, they have certain management challenges, right? Because the purpose of the big data tool is to make management of a large amount of data as simple as possible as we can do. But it is not that easy, right? So data management in NoSQL is much more complex than a relational database, right? And there is no graphical user interface that is available with the NoSQLs, right? So they are not very much flexible graphical user interface tools that are available to work with the NoSQL. And documentation size is something which is very huge when it comes to NoSQL databases. So there are more advantages and less disadvantages, but definitely, right? So some of the examples, if you talk about, right, we have Hive, right? You have, you know, MongoDBs, right? So there are multiple, the NoSQL DBs also which are available, which are used by the organizations like Facebook, Paytm, and all to manage all their big data today. Right, everyone? Okay. So now, as if I talk about the tools which we talked about, right? NoSQL and programming languages. Now, similarly, right, the other competencies, right? Other competencies which companies look out for a data engineer is, right? They are basically, right, first of all, a logical mind, right? You should have good aptitude skills, right? You should be good with aptitude thinking, right? You should be able to understand what to extract from data, right? You should be able to work with the cross-functional teams, right? So these are certain tasks, work with the cross-functional teams. So these are some of the important, asks that you will always have when you are working with, the when you are working with this into the data engineering field right now, right? So basically, when it comes to, right, when we talk about data scientists, right, data scientists have normally main four tasks in the company. They will be analyzing, testing, creating, and presenting the data to the team, right? They are mostly the people who are from the mathematical and statistical background, right? Whereas, these, as we were discussing like previously, so over here, so the data engineers are the people who are more into data architecture or designing of this data now. Okay, right. So over here, right. So because of this data, so there are a lot of tasks and things that are happening, and that is what we have been talking about right now over here, right? So some of the areas, right, where this data engineering has actually helped us, right? So data engineering is something which has been used, for destroying, the human trafficking networks, right? In the medical industry, right, data engineering and data science fields have actually helped the institutes to understand various diseases and come up with a cure of that, right? In rocket science, this is something which is being used. So now also, even with this huge development, that has happened across the organizations, right? Still, only 27% of the big data projects are regarded as successful, right? Because what is happening is this is a field which is still into the evolution, and there are still a lot of technologies, concepts that are coming. The talent is still getting, kind of nurtured into this area. So still there is a big scope and a big gap that the companies have, due to which they are not able to have the very successful transition over here. Okay, so now when it comes to, this complete data science field, right, data engineering field, so data scientist is not just one person. There are multiple teams and organizations and the things which are actually going to work together in order to sustain, what insights and outcome we are all going to come up with. Okay, so if you just have a look at it, so this is how, the complete a data hierarchy is something which actually sits in an organization, right? So data engineer is a person who is responsible for ETL tasks, setting up the data in the pipelines. Data scientist, he's the more like a person who will be setting up and coming up with the insights. And there will be business guy, right? Subject matter executive, right? Subject matter expert. Now he's the guy who understands the business well, right? Like for example, if I'm talking about retail business, now in retail business, the data will be different. The kind of analysis that would be required would be different. The kind of, you know, the outcomes that would be expected would be different, right? Like for example, in retail organization, like there was, one project that I was working upon, right? That was about ranking of the products. Okay. Now we all know, right? Let me tell you a small example. So we all know that what happens is that whenever you go to any of the supermarket, right? You all go to a supermarket. You all would have seen in the supermarket, they have the aisles, right? There are aisles that are there. In those aisles, the products are kept, right? There will be a section of cosmetics. There will be a section of beverages. There will be a section of, the groceries and all. There are different aisles that you have. Now, what happens is the space is limited in a store, right? In any supermarket that you go, the space is limited. You cannot keep every product, every brand, every size, right? Because you don't have that much space with you. So how do you decide what items to keep? And if suppose, like for example, it happens that there is a new product launch that has happened. Now, if the new product has been launched, so definitely the requirement would come up that let's place that new product on the aisle and let's remove one of the products from there. Now, most of the people, right, they will think that, okay, the product which is having the lowest sales, remove that, right? Most of the people will think that, okay, the product that is having the lowest sale, let's remove that and place a new product instead of that. But that is not the case, right? Because you have to understand that which product you remove so that you have the minimum impact on your transactions. So for that, you will need sales data, you will need volumes that you are selling, you will need to have customer data as well. Customer data is something which is in the form like, if suppose there is a customer who does a lot of shopping from your store and there is one particular product which sells very less, but he buys that product every time, right? So if you remove that product for a new brand, so there are high chances that that customer might not come to your store the next time because his all the products are now not available on that store. So he might, refrain from coming to your store right now. So that is where, like that customers transactional data has to be analyzed and understood, that who are the customers who are loyal to a product, right? Who are the loyal customers, right? Like the loyal customers are the ones who will always buy the same brand, same product every time when they come to a store. And whereas, there are disloyal customers, and these are some people, what they will do is they will always, change their preferences or they will change their priorities depending upon what is on the offer, right? If there is a guy who says that I want to just buy cheaper cold drink, so if the discount is on Coke, he will buy Coke. If there is a discount on a Pepsi, he will buy Pepsi. Whereas a loyal customer is something, he will always buy Pepsi only, whether it's expensive, it's on sale or not. So they are loyal customers. So if you have a loyal customer and if you remove their product, definitely you will lose your market. But if the customers are disloyal and then you remove the products, then you have better chances of not losing a customer because he will definitely switch very quickly, right? So now when it comes to, right, this is where the competencies, right, we were talking about. So other competencies, a data engineer must should have is good analysis, right? That person should be having good hypothesis creation, right? He should have, broad knowledge in terms of data mining, right? He should understand statistics, right? The person should understand big data infrastructure, right? And that person should be a problem solver, right? These are certain skills that the organization will look like for these things now over here. Right now, as per the latest, if you talk about, you know, the jobs when it comes to data engineering, right? And you talk about the job pays of the data engineers, right? So on an average, right, according to the US markets, the average salary of a data engineer is around, as per the Glassdoor, I am telling, that is 1,39,840 per year, right? Which is being given by the Glassdoor, right? And, when it comes to, you know, uh, more, right, data science and all, so definitely there are again different data packages, but this is something around 1.4 is the average that goes around in the, as per the US economy and the job trend that has been seen. And definitely, this data science, data engineering is definitely a growing sector, right? And the reason for that is definitely the good salary. You get challenging tasks and assignments to work upon, right? So that is where, this is why, this industry is really breeding, I will say growing right now. Okay. Okay. So you will find, right, a lot of things, right? How to become a data scientist, data engineer. So a lot of stuff that you will find over here. So now just let's try to understand how that complete flow of the things happen. Okay. See, first of all, what happen is you have to define a problem, right? What data problem you have. Then what happens is there is a complete, you know, acquisition or acquiring of the data that happens. You do a data exploration and you do the analytics on that, right? And based on that, what happen is there are models and descriptive analysis that is done on the data. Now, this is something which a data scientist is doing, right? Now, when it comes to a data engineer, he's a person, who is creating the complete data flow architecture, defining the data schema, doing the feature extraction, creating the data flow implementation, and finally data flow validation as well, right? You also have to validate all that data that you are generating. Is it of the good quality, and is the data that we are generating, is it fine or not? So all these things are being done at a data engineer level, and all this data that we generate over here. So that is what sets up the base for the data science as well. So if we try to understand, the importance of the process, so this is something which is going to help, you know, have some productivity tools, because, if you have a proper data with you, that is going to help you with the productivity tools. It is going to help you, with the shared and distributed resources, and you will have more of standardized documents, templates, and you will have a proper standard project life cycle, right? So which is, you know, there is a term that we use in the software development also, which is SDLC, software development life cycle, right? So these are certain things that we actually do as a whole process or a part of the complete data engineering now, right? So documentation, data, coding. So all these play a part of that, because the documentation is also plays an important role, because if something changes in the future, so the other person who comes into the play, he should be able to understand how the data pipeline was created, and if certain modifications are required, that person should be able to do that up. Okay, right. So now, what happened is when we talk on data engineering, right? So the questions have to be assigned beforehand, what questions that needs to be answered with that data, right? Predict whether like for example, you want to predict whether the component X will fail in the next Y days or not, right? You have to, you should have the identifiers with you. What are actually going to help you, that what are going to make sure that, whatever you are going to use for an analysis, are they the good way of predictors or not? And you also have to ensure that the data that you are, acquiring, it has to be accurate, right? If the data is not accurate, so definitely you are bound to fail in all your analysis and root cause analysis that you're going to do now. Okay. And finally, data has to be connected, right? So as we discussed in the very starting, the data is something which is going to come from different sources. So we should be able to link and convert that data into the form of an information. Okay. So then finally, you will have a lot of data which you will be using for machine learning. So you will be, it will be difficult to predict failure accurately with few examples. So you have to make sure that you have a lot of data with you, which can actually help you come up with more robust analysis. Now, this is something, which sets up the complete base for the data engineering, right? So how do these data engineers are actually going to spend their time, right? So they will be responsible for cleaning and organizing the data for 60% of the time, collecting more and more data sets, setting up data mining, right? Refining algorithms and building training data sets and others, right? So as per, Gartner's estimation, that poor quality of data is something which is actually leading to the, the loss of almost like, on, average of 13.5 million per year, right? And this trend is actually getting further degraded as more data is getting generated. So when we talk about, right, this data engineering, other tools which play an important role over here is that is basically right Kafka, right? Kafka is something which is used a lot, right? And this is used for the data ingestion, right? We use Spark and Hive as well for processing of the data, right? So Hive is something which is used majorly by the large data-driven organizations. Okay, this is something which helps in better and faster processing of the data. Okay. And yep, so as per the cloud era and everything, if we talk about over here that how the demand has been increasing, we can see that in terms of data engineering, right? In terms of data science and BI. So this is something that we have over here right now. And all the things are getting deployed in the cloud enabled environment. So right, having the knowledge on GCPs, AWS, Microsoft Azure, VMware is also something which would be so we were talking about, the flexible deployment that is cloud enabled, right? So this cloud enablement, in the data engineering is something which is going to actually help you in easier administration and, flexible deployments. You can always plug and play, increase your performance like we discussed in the starting as well. Okay. So, basically these are the latest tools that you should be exploring, for data engineering, right? So for information management, right, we use data factory, right? This is the data source. Applications are used like data catalog, right? For big data storage, we have data lake stores, right? And we have the applications like SQL data warehouse, right? For machine learning and analytics, the machine learning algorithms, data lake analytics, Hadoop and Spark and streaming analytics, right? For then finally, for BI, right? Business intelligence. So what we do is we use dashboards and reports in the organizations. So with the data, you to move towards the intelligence, and that is when you are able to take the decisions. Now in every organization, what is happening is all these things are used, are something which are getting used together. And and as this technology is getting more and more robust, you will actually see that how these things with different applications, right? Today we are able to use all this data through this complete platform on the web. This can be accessed on the mobile, and this also helps the bots, right? Today these days what has happened is, like you all would have noticed, right? What happened is whenever we log on to any website, there is a pop-up comes up, right? Hi, what's happening? So over there, that's not a person who is sitting, it's a bot, right? What that bot is doing, it's just talking to you. And this bot is something which is connected to all your data, that data flow and data pipelines that are there. So the moment I type your question, what that bot does is it goes into the system and finds the answer for you. So that is where the automation comes into the picture, right? So we have now more of automated systems which are getting created because of this data engineering. Okay, so if I quickly summarize, right, so more data will give you more results. It will help create a data-driven culture and data science processes. You can carefully, check the data, clean the data, and you will have to use the right tool for the right job. And that is how the things get cloud enabled, right? So the 5 points that how the things have changed for a data scientist is something what we are talking over here right now. All right. So now, there are certain, we will share these links also with you where you can access more about it and understand more about data engineering. But yeah, if you quickly understand, right, so some of the skills you should need to, kind of buckle up are something that would be your SQL, no SQL, right, Python programming, right? You will have to, Scala, Hive, right? So not all the programming languages, I would say, or all the skills, but at least you need to learn few of them so that you have a better portfolio that you can manage for a data engineer job, right? Also, you will have to work on your aptitude skills, guesstimates, right? You should start working on the guesstimates as well to create your, analytical thinking, I would say, right? So these are certain tools and technologies that you should be, something you should be investing your time and energies in. And yep, so this is what we have. Thanks, guys.